Hi everyone, I'm Yamini, and today I'll be presenting an update on ONNX GenAI working group and will represent the work by several members in this group. So this working group is actually a newly formed working group to evolve the needs of ONNX in the GenAI space. And today I'll talk about the scope of this working group and the work streams that are currently in progress. So in this working group, we covered the entire deployment journey, starting from the framework model like PyTorch, and then walk through all the steps like exporting the model and applying optimizations, quantization, and all the way to deploying the model using the GenAI pipelines and the solutions that we saw today. So we divided the work into 4 major work streams. The first one is ONNX standard, where we are identifying the missing generative AI operators and functions in the ONNX standard. And as part of this effort, we are looking into adding new ops so that we can represent the popular models. And the second work stream is around ONNX exporters. So today, actually, Justin presented the ONNX converter effort. So ONNX exporters work stream is mainly to understand the gaps that are currently present in the export process, and also to make sure that whatever ops or functions that we define in the ONNX standard, they are getting exported properly as part of this export process. And the third work stream is backend specific representations. This is mainly to capture ahead of time compiled objects, and also like different backends have different quantization formats. So the idea is to define ONNX constructs to capture these backend-specific representations efficiently. And the fourth work stream is around pipeline constructs or interfaces, where we don't just look at the optimization at the model level, but we look at the pipelines, end-to-end pipelines, and consider all the aspects like tokenization, embedding, decoding strategies, and so on, and address the fragmentation that we have in the GenAI solution space. So let me deep dive into what we are doing in the ONNX standard work stream. So as part of this work stream, we are analyzing the missing operations and functions, and we are adding them into the operator spec. And we are looking into supporting different operations, including attention, specialized activations, and normalizations as well. And today, actually, Rama also covered the flex attention aspect. So we are looking at representing different attention variants, like sliding window attention and causal attention. Actually, there are many attention variants that Kunal showed in his presentation. So the idea is to use the flex attention concept from PyTorch to efficiently represent these different attention variants so that it's easy for the backends to support these variants. And then we are also looking into KV cache management updates. So Yuan actually brought a proposal to the working group to update the attention operator spec to support the KV cache management more efficiently. And we are also looking into optimizations like in-place caching and stateful transformation. And we're also looking into the quantization enhancements, where we are enhancing the operator semantics to include any special quantization formats needed by the backends. The second work stream is on the ONNX exporters. So as Justin mentioned, we are primarily focusing on the torch.onnx.export, given the popularity of PyTorch. And given that the primary path to export capture and export the graphs is with Torch Dynamo, we are actually focusing on torch.onnx.export with Dynamo set to true. And there is a link where Justin actually has a detailed diagram of explaining the entire export process. So please feel free to refer to that. And besides the torch.onnx.export, we are also looking into higher level exporters like Optimum Export, because it's easier to use and export the models from transformers directly. And some of the activities that we are doing as part of this work stream is identifying the gaps that we currently have as part of this export process. And I think somebody asked a question about can we really preserve attention operator, because currently it's getting decomposed. So that's actually one of the examples of how we want to retain the functions so that the backends can use these functions to map to their fused kernels. And also, if they don't have fused kernels, they can always decompose the function and map to their primitive operators. The next work stream is the backend specific representations. So here the goal is mainly to define ONNX constructs to express the ahead of time optimized objects efficiently. And the main reason for this is as GenAI models become larger, we have long compile times, particularly for devices like GPUs and NPUs. And the idea is to store this ahead of time optimized objects in the ONNX model so that it's easier for the runtimes to import those compiled objects and deploy them. And this is actually building on top of ONNX runtime's EP context design. And we are looking into various aspects like weight sharing, weight-free blob compilation, and also representing multiple backends in the same ONNX model. So in this case, like weight sharing actually becomes very important. So we are looking into all these aspects, and the proposal is currently under active development. So if you have any ideas or any real-world issues that you are encountering, please feel free to reach out to us. The next work stream is on pipeline interfaces or constructs. As I mentioned earlier, like we want to look into the entire pipelines, end-to-end pipelines, starting from tokenizers, embedding models, decoding strategies like greedy search, beam search, and I/O constructs to consistently represent the input-output flows, and also like capturing some of the common optimizations that we can use. So the purpose of this work stream is mainly to define those high-level interfaces so that any GenAI solution can use it, and like we can improve the adoption of ONNX in the GenAI space using this. So here are some of the logistics. So we have the main GenAI Slack, and we also have different Slack channels for the work streams. The pipeline interfaces work stream will also start soon. And the meeting minutes are present in GitHub. And we have a weekly meeting. We had about 6 meetings so far. So if you have any new proposals or any issues that you're encountering, please feel free to reach out to us. And we welcome your contributions to increase the adoption of ONNX. Thank you.